Let's finish up this packet with one more application problem. We're looking at reasoning. We're looking at, can you show, how do you explain, what do you do? So the division property of exponents says that to simplify powers with the same base, you subtract the exponents. So we're going to use examples. We're going to make up examples to show why the powers need to have the same base in order for this technique to work. It's got to have the same base. That's the issue. All right. So we know that if we have, I don't know, e for example, to the fifth power divided by e to the third power, we could expand that. That would make 1, 2, 3, 4, 5 e's. 1, 2, 3 e's. And we can cancel out 3 of them from the numerator and the denominator, leaving you with EE, which becomes E squared. And we know from the quotient rules that we could have, at the very beginning, just said e to the 5 minus 3 and gotten that e squared. All right. So this is the rule, and here we showed that it works as long as the bases are the same. All right. So let's go find out about if they're not the same. What if I have e to the third and x squared? Because 3 plus 2 makes 5. So why not that? Still divided by e cubed. Okay, so this gives me 1, 2, 3 e's and a couple of x's over 3 more e's. And again, my e's get to cancel, but I'm left with x, and that's x squared. So what happened with the rule? The rule showed that we had e to the third power minus 3 times this x squared. Because the e's are gone. Where did they go? E to the 0 power, because 3 minus 3 is 0, x squared. So the base has to be the same in order to get the same final answer. There might be a temptation to say, what, they're both squared, so who cares? Well, that would go back to, well, what was e worth in the beginning? What was x worth in the beginning? You could say, well, e might have a value of 9. I don't know, my youngest child is 9. And x might have a value of 13. I don't know, another one of my children is 13. So if I plug those values in now to see what is created, we had e squared. So that is 9 squared. 9 squared is 81. And we had x squared, which is 13 squared. That's not 81. That's 169. Not the same. The idea is that each different variable potentially has a different value, and we have to account for that. Yeah, you're right, sure. They might. might have the same value, but the vast majority of the time, they're going to have different values. So we have to acknowledge that and account for it. So this was 2 ways to show that the bases must be the same in order to use our quotient rule, our division property that says just subtract things out and you'll be good to go. Okay? All right, so I need you to do number 10. Just finish this up, and if you're stuck, bring it to me.